Why do you think the Hubble telescope, the mirror issues notwithstanding, which were ultimately fixed when it was first launched, why was that so successful? There were versions of the Hubble telescope previously launched by the military, looking down. The model for that telescope had already been conceived and built and was operating. Then we said, oh, we want one of those. Okay, but that's not public that this is going on. The telescope gets designed, it has the benefit of previous versions of it having been used successfully, but looking down, and we look up. This is the perennial two-way street of astronomy in the old days and in modern times astrophysics. And the invention of the telescope. You haven't said anything yet. Oh, you're a good listener. Should I keep talking? or am I preventing you from interrupting?
Don't worry, keep going. Don't worry about me.
Okay, fine. Galileo perfects the telescope. He learned that it had just been invented in the Netherlands. The Dutch were opticians, all right? So they invented the telescope and the microscope within a couple of years of one another. This transformed science.
When did they invent the eyeglass, the reading glass?
The reading glass, earlier than that, but I don't know when. The real advance was putting two lenses in line with one another. Sounds trivial in modern times, but that was a huge leap, conceptual leap in what you would accomplish. And in so doing, depending on how you curve them and how you grind the shape of those lenses, you would get a microscope or a telescope. And we're off to the races. That's basically the birth of modern science as we now think of it and conduct it. Because you say to yourself, my senses, I don't trust them to be the full record of what's going on in front of me. You pull out a microscope, oh my gosh, Leeuwenhoek, he got the microscope guy. He got a drop of pond water, puts it under his microscope just to think to do this. It's just water. Why do you think that's something interesting to do? He said, I wonder. He was curious. He puts it under and sees little, what he described as animalcules, happily a-swimming.
Animalcules.
Animalcules. These are like the amoebas in Paramecia. And, it is, and so he reports on this to the scientific authorities, and they don't believe him. They say, Van Leeuwenhoek, we think you might have had too much gin before you wrote this letter. Why would anyone believe this? That there's entire creatures, an entire universe of creatures thriving in a drop of pond water. And so the way science works is one report does not make it true. You need verification. They sent people to the Netherlands to verify his results. And there it was, the birth of microscopy. And then they looked at everything. Cells, you need vocabulary to describe what you're now seeing. Well, that was the journey down small, then the journey went up big. And Galileo perfects the telescope. He looks up and says, whoa, I see craters, mountains, valleys on the moon. The sun has spots. Venus goes through phases. This became the corpus of evidence for Earth going around the sun in support of Copernicus's idea that Earth went around the sun. My point is, what was the second thing he did with his telescope? He contacted the Doge of Venice, invited him to the clock tower, and said, look at what this instrument can do for you as we look out into the lagoon. You can identify a ship's intentions, friend or foe, by its flag 10 times farther away than you can with the unaided eye. Venice bought a boatload of these telescopes in the service of their military defense. And this was a source of money to Galileo. Now he could go look at the universe. This has been a two-way street ever since people have looked up. So this is an accounting of that. It goes on and on. The first X-ray machines for airports. You're old enough to remember. Why were they put in? Because of hijackings to Cuba, basically. They were armed hijackings of airplanes, of American carriers to Cuba. And Congress said, we got to do something about that. Oh, by the way, there's a company in Boston called American Science and Engineering that was building an X-ray detector small enough to put on a satellite to observe the universe in X-rays. And because no one we've used visible light, but not X-rays. That's a branch of the electromagnetic spectrum. We think if there are black holes out there, their region surrounding them will give us X-rays. It's a new window on the universe. And then they said, oh my gosh, there's a call for X-ray machines at airports. We've got the technology that we've perfected to put in a freaking satellite.
So the technology for those ones you walk through at the airport initially came out?
Initially, yes.
Wow.
Yes. There was a two-way street. There was, oh my gosh, we need this for security. Oh my God, we were using, let's apply that technology to these detectors.
Well, that's been a lot of the stuff with the space program, right? A lot of the stuff that they devised for use on the space station and many other technologies have trickled their way down into regular society.
That always happens, and even some simple things. Because people say, why spend money up there and we should be spending it down here? But there's an interesting fact here that is almost never discussed. The people who think about the universe and study the universe are hugely creative. And the creative energies cannot be pre-prescribed. You can't go to you might, but I don't know that you'll get their maximum creativity. Say, I need you to invent a cure for cancer right now. Use that brilliance. I'll try, but the greatest discoveries, the greatest cures, the greatest of these comes from a cross-pollination of interests that people have where they were engaged because they were interested just for the sake of being interested. So watch what happens. Here's an example. The space shuttle. It's a glider when it lands. Okay, it's got no engines. It's got flaps. There's a little bit of brakes in the tires, but that's about it. When it comes in, okay, how do you make sure the thing stays on track? Because they kept drifting and crosswinds and this sort of thing. And so they said, why don't we groove the road so that the rubber on the road, the runway, so that the rubber can align with the grooves and stay in a straight line, because rubber doesn't slide well doesn't slide sideways very easily on grooves. When they realized how effective that was, it's now put on off-ramps to freeways. If there's a freeway off-ramp that's a little tight, not quite banked well enough, it's going to be grooved. Check it out next time. And you could say, well, okay, that's pretty simple, low-tech solution. Why